Hey guys, welcome. So may the Lord Christ bless you, bless me, and this video we have a really cool integral here. Okay, now notice that we've got 1 over 1 plus x squared in this part that we always associate with tan inverse. So with that in mind, the way we should start this integral is by letting x equal tan theta. If x is equal to tan theta, notice that it would mean tan inverse of x is equal to theta, right? And then taking the derivative on both sides of this here, we see that 1 over 1 plus x squared dx is equal to d theta. And of course, this amounts to saying that dx is equal to 1 plus x squared d theta. Additionally, notice that this lower limit, 0, which is about x, is now going to be about theta, and so it's going to be tan inverse of 0, which is 0, right? When we switch to theta, this 0 will remain 0, is what I just said. And this infinity will become tan inverse of infinity, and that's pi over 2. So our limits are going to be from 0 to pi over 2 when we switch to theta. So then the given integral is the same as 0 to pi over 2, and then it's going to be the natural log of, we said tan theta is x, so then 1 over x is going to be 1 over tan theta, which is cot theta, so cot theta, and then we'll have 1 over 1 plus x squared, and then dx, however, is this here, which is 1 plus x squared d theta. I know it's gonna run out of room. Okay, so that means we could do this, and so all we have back here is just d theta, right? So cool. So d theta, and also in this part, in the interest of sine theta over cosine theta plus cosine theta over sine theta, right? And if we get common denominators in this part, we're going to get that we have integral 0 to pi over 2 of the natural log of sine squared theta plus cosine squared theta all over sine theta cosine theta, that, right? Now we know that sine squared plus cosine squared is 1, right? Right, so we do that, and then we know that the natural log of 1 over a is the same thing as the negative of the natural log of a, right? So exploiting what I just wrote down, we can write that what we have here is the same as negative of the natural log of sine theta cosine theta, and the negative I'll write right there. Okay, cool. Now where to? Well, we could try and use the sine double angle identity, and so specifically we could replace sine theta cosine theta with sine 2 theta divided by 2, but instead let's do this, which is let's use the log product rule and write this integrand as the natural log of sine theta plus the natural log of cosine theta, and then of course all this times d theta inside the integral, right? Okay, cool. Now in Fun Challenging Integrals Part 79, I show you how to do the integral of the natural log of sine theta. There, and from 0 to pi over 2. And there we said that the integral from 0 to pi over 2 of the natural log of sine theta d theta is the same as the integral from 0 to pi over 2 of the natural log of cosine theta. And so I'll leave a link to that video, and you could watch that video for these details. But what I'm saying is as long as we have 0 to pi over 2 here. The natural log of sine theta integral is the same as the natural log of cosine theta integral. So what we can do is follow this minus sign with a 2, and then we could just erase this part and scoot the d theta closer. Now, in that video that I just referenced, we did this here, the integral from 0 to pi over 2 of the natural log of sine theta d theta, and we found out that it was equal to, right, it was equal to negative pi over 2 times the natural log of 2. So the answer to the integral we're working on now will be get rid of this minus 2 by this minus 1 over 2, and so it'll just be pi times the natural log of 2. Yeah? Okay, cool. I dropped it.